Welcome to this session. In this session, let us try to understand the important concept that is a network application architecture. Okay. So we are currently understanding the network layers, right? So to understand those network layers, this concept's understanding is important. So that's why I thought of covering this concept. So in this session, we will try to understand it. Okay. So before that, just to make you people curious, right? Let me ask some question. Everybody use Netflix, right? Everybody watch movies on the Netflix, right? So how does Netflix stream videos smoothly to millions of user at a time, right? How does Netflix does it? Now we are using Bitcoins. So how Bitcoins work without central? It doesn't use any server for its working, if you know that. So how does it work? So you would have also seen some small website. If multiple people log in, right? Multiple people log in on the same website, it will get overloaded or it will get broken. But YouTube, if you see YouTube, it can handle millions of people and it runs millions of video at a time. But still it doesn't break. It still works. How that is possible? All these things are realistic scenarios, right? So but have you ever wondered how this is happening? So in this session we will try to understand the magic behind it. So what are the real life problems we are having? So for example, you build a website and 1,000 users log in into it, it is breaking. So you build a file sharing website where you are sharing the file. Now everybody sharing the file and your server got overloaded. So all these different examples, right, need a different kind of communication mechanism. Okay, different kind of communication mechanism. If you don't follow a different kind of communication mechanism and you keep on following the single mechanism, then what are problems you can face? Your server will get overloaded. Okay, it will get overloaded. Your network will get jammed. Then millions of requests fight for the same resource, and you might have a multiple system in your application. One system broken and it breaks entire your application. Your data, you are storing it at one location, and if someone access from other location over the globe, right, so he get a lot of delay in accessing your data, so your data couldn't scale properly. So all this problem, who addresses this problem? The hero which comes to rescue all this problem is network application architecture. So what is network application architecture? Now our session starts. So architecture decides who talks to whom, who should talks to whom, and in your communication, in this communication, how many machines should be there in the middle? Who decides that? It's architecture who decides it. Where your data needs to get stored, DB, that is also decided by your network architecture. If any failure happened, for example here, how this needs to be handled, then how your system scale in case you have a millions of user coming up joining, right, how your system should scale. All these things will be decided by your architecture. So we have, based on our different kind of requirements, right, we have a different kind of application architecture. So network application architecture, in simple words, it says that how computers communicate to deliver a working application. So it's decide whether your machine should be centralized or decentralized. You should use one server or you should use multiple servers. How communication needs to be done? Is it direct one-to-one communication, or there should be some middleman in the process of communication? How data flows between this machine? Then how app scales when user grows? How this needs to be handled? All these things will be decided by network architecture. So what are the different kind of architecture we are having? So there are some famous network architecture available. Okay. So the first kind of network architecture is client server architecture. So what happens in this is you have a client. Okay, you have a client and you have a server. Okay. So client request for some website via browser. Okay, and your request sent to the server and server will respond to the request. So it's simple, like you as a client place an order in the restaurant. The waiter here, the network takes that order and send it to kitchen. Kitchen is a server here. Okay, kitchen is a server here, and this kitchen prepares the food and send it back. So kitchen is important here. Kitchen is a server. So kitchen is important here, means server is important in the client server architecture. If your server went down, your application is gone, right? So real world example of these architectures are websites. If you see, then banking apps, Gmail, online shopping, Amazon online shopping, all these things, Instagram, all these applications uses client server architecture internally. There are some benefits of client server architecture. The benefits are easy to control. It is easy to control. Control is good. Then easy to manage. Then secure and centralized. Right? Everything is present at one location only. That also gives a risk of one single point failure. So if server fail, your app failed. App failed. So that is the client server architecture. Many companies, whoever develops applications and all, right, they mostly use client server architecture because it is very easy to implement and it works well. That's why. The next kind of architecture which we have here is your peer to peer architecture. So in peer to peer architecture, what happens is you have one person, here is another person. This is a client, you can say. Okay, this is another client or another person, another user, but they communicate with each other. There is no server. So for this client, this another client act as a server peer. That's why this is a peer, this is a peer. That's why it is called as a peer to peer communication. So whatever this guy needs, if this guy has that, he will send that information. In case this guy doesn't have, then it will move to the next guy. If does he has this information, if yes, then he will send it back. So there is no server in this architecture type. Okay, so every point act as a server on its own. So you can have multiple peers acting as a server. One very famous example of this kind of architecture is your torrent. So BitTorrent, some people will be using BitTorrent. So that's why you would have heard, right? Torrent is basically, it is holding most of the pirated data, right? So many countries want to ban it, but nobody is successful in banning them because the architecture which they uses, right, that is a peer to peer architecture. So they don't have a single server or some multiple set of servers that the police will go and shut down those servers. That is not possible. There are many peers who are located geographically here and there, which are unable to track itself. So how many peers the police will stop? It's very hard, right? Because every peer whoever join, right, whoever install the BitTorrent, he himself act as a server, right? So it is very hard to stop this peer to peer architecture in BitTorrent and torrent. Another very famous example of this type is Bitcoin and blockchain. So here also there is no server, everything works on peer to peer. Then some LAN gaming, you would have heard of this concept where one system will be connected to the other system and both the player plays and the communication happens between the system. There is no server involved. So that kind of application uses peer to peer. Now what are the strength of this kind of architecture? So the strength of this kind of architecture is no central point of failure. So even if any hop got failed, other one will be there to serve the request, and it is highly scalable. You just install the application, in this case torrent for BitTorrent example, and it acts as a another hop, right? It's very easily scalable, highly scalable, and load is shared among the different peers. So there is no question of overloading. If one client got overloaded, load will be shared to other one. So there is no overloading. And what are the weaknesses now? It is very hard to secure. Security is a challenge. Then coordination. nobody can coordinate. So that's why nobody able to stop the torrent, because you cannot coordinate between the hubs, right? So that is about this peer-to-peer architecture. Next type of architecture is a distributed architecture. So this is actually a real-time architecture. Means it is getting used by most of the companies. So what happens is, if your organization is big, right? So you will have a billing department. You have a search, then you have a recommendation, for example, then you have a user service, you have an employee service. Each team handles its own job or task, and they work together and make a company. So this is a distributed architecture concept. So similar thing happen in the digital world. So your application, you will have a set of multiple application, plethora of application, and they combine and make us a big application. That is called a distributed architecture. So example are microservices. You will have a payment service, you will have a shipping service, you have a employee service, all these services. You have a distributed databases, distributed DBs. Then you will have a CDNs. Then you will have a Kubernetes cluster. So all these things, distributed databases, CDNs and Kubernetes, will help you to distribute your load. For example, distributed database, right? So it will help you to distribute your data between the multiple DB servers. CDNs. What CDNs will do? It will help you to to keep your frequently accessed data to the nearby user location. So there will be multiple CDNs available. Okay, it will cache the data. So all together, these things make a distributed architecture. So benefit of this is it is extremely scalable. Scalability, because it's a distributed, right? Microservices. You can add multiple microservices in the scope. Then it's a fault tolerance. If in one of the microservice fail, other will be deployed or it will be replaced by the other, right? That is also possible. And independent services. You have an option of independent services. You means if you have a small task, right? That small task, for that task also you can create an independent service. So you don't have a multiple tasks done by a single service. So that kind of provision you can do it in distributed architecture. So weaknesses is it's a complex, hard to debug, and require a strong DevOps culture to troubleshoot, to deploy, and all the deployment related stuff. Then we have another type of architecture, that is hybrid architecture. So what is this architecture is? It combines everything, whatever we have seen. Client server, peer to peer, distributed, everything will be combined into hybrid. So for example, for login in the application, you using client server. For video delivery, you are using CDNs. For live streaming, you have a edge nodes, means you have deployed the servers nearby your locations. For recommendations, you are using microservices. You have a service for recommendation, right? For different tasks, you have a different kind of things. So all these things, if you make use of all different kind of architecture into one, then that is called as a hybrid architecture. So whatever problems we discussed before, right? If the website crashes under load, then distributed architecture with load balancing or microservices you can use, right? If your central file sharing system is getting overloaded, then you can use peer-to-peer communication, right? So we have seen those problems before, these problems, right? These problems. So for this, you can use that. Then if you want to stream the videos globally, like what YouTube does, then you need to use hybrid distributed architecture plus CDN. So different things has a different use cases need a different architecture types. So network application architecture is a actually a master plan that decides how computer talks, who manages data, how apps scale, and how the internet works at global scale. So all these things included in the network application architecture. So that's all in this session. So if you like this session, do like this video, share and subscribe to this channel, and feel free to share it with your friends.